Hello there, my name is Maher Haddad. Today I'm going to show you how to make a configuration for a very complex CCNP lab for OSPF, of course, OSPF routing. We go to the website and we check the steps we need to do. So this is our network. We have 9 routers. We have area 0, area 25, area 367, area 48 and area 89. So let's read what we have here. Configure OSPF process on all areas as shown on the graph with router ID XXXX, where X is the router number. Okay, so let's do that. Router 1, router OSPF 1, create router ID, and make it bigger. 192.168.1.0. Okay. Let's also look back. Let me check if I have look back here. Yes, I do. So okay, that's router 1, router 2. Okay. Oh, I have to do the router ID before. Now I need to clear the process. That's for area 25. Now loop back. Okay, we jump to router 3. Let's check this router 3. It is on area 365. And loop back, of course. Go to router 4. And this one is router 4, area 48. Okay, now area 5, router 5. 9, yes. Router 6. Router 7. It takes a lot of work, but it's a nice review. Know how to configure OSPF. Router 8. Let's check. Router 8 is on area 48 and 89. Finally, router 9. I'll clear again the process. Okay, so let's check what they're asking here. So after we configure OSPF, they asked to ensure that R1 can ping all routers on the lab, so we have to try to ping all loopback. Otherwise, you should find the problem and solve it so R1 can be able to ping all routers on the lab. Okay, so let's go to router 1. First, let me do a show IP route. So 2, 3, 4, 5, and 8 are okay. So let's check on the graph. So I can ping 2, 3, 4, 5, and 8. But 6, 7, 9, I cannot see them. We can see here that this area is not connected to the backbone, so for sure this router will not be shown as an inter area. And the reason why, because all areas should be connected to the backbone area, which is area 0. So in this case, if we cannot connect it directly to this area, what we can do, we can make the area 48 as a virtual virtual link area. So there will be like tunneling in over here. So router 89 would be considered as connected directly to area 0. To do that, I have to configure the virtual link between router 4 and router 8. So I go to router 4, router 4, and yeah, inside the router process, I say area. What was it? 48. Say area 48 virtual link, and then I have to say the router ID. The router ID of router 8. So router 4 should put the router ID of router 8. Very important to say that router 8, if you change the router ID, then the virtual link will go down. So here router 8. First of all, let's check. Do a show IP or OSPF neighbor to ensure that this is router ID. That's correct. So area 48 virtual link 8.8.8.8, and then I go to router 8. I will do the same. I say area 48. Before I do that, let's do show IP or OSPF neighbor. And then for okay, this is router ID. So area 48 virtual link 4.4.4.4. Okay, with this I have created the area 48 as virtual link. To ensure that everything is fine, I can do show IP OSPF virtual link, and you see it's up. So now if I go to router 1 again, I should be able to see 9. So let's try and check. So 2, 3, 4, 5, 8, and 9. So that's okay. So we are still missing here. We are still missing 6 and 7. So let's check what's the problem over here. We go to router 3. We have 3 is the hub, and these are the spoken. We go to router 3, and let's check show IP OSPF interface serial 0.0.1. So the type is non-broadcast. Okay, that's router 3. Router 6, let's check. Show IP interface serial 0.0.1. Oh, sorry. Show IP should be show IP OSPF. Alright, so it's point to point on 6, while on 3 is non-broadcast. And on 6, because it's point to point, the hello is 10, while here is 30. So for sure they will not form any adjacency. So if I do show IP or OSPF neighbor, router C is not forming with 6 and 7. So first of all, we have to change the network type to be non-broadcast on router 6 and router 7. And directly the hello will be changed to become like here 30. So I go to router 6, interface serial 0.0.1, IP OSPF network non-broadcast. I'll do the same on router 7, interface serial 0.0.1, IP OSPF network non-broadcast. Okay. So now if I go to router 3 again, I'm going to show IP OSPF neighbor. Okay, then that is one of the steps we have to do. So we have changed to non-broadcast. So let's verify that. On router 6, I do show IP into IP OSPF interface serial 0.0.1. So here we are. It's now non-broadcast. And 7, do show IP interface, show IP OSPF interface 000.1. Now it's non-broadcast. But as it is non-broadcast, there's no hello going from one page to another. And here you can see that directly the hello has changed to 37. So what we need to do is we have to go to router 3 and send a pseudo broadcast. And to do that, I have to go to router OSPF1 and I have to put this command. The neighbor, let's check the IP address, 192.168.3.6 and 3.7. I do neighbor 192.168.3.6, correct? 3.6, yes, and neighbor 3.7. And this way we are sending a pseudo broadcast from router 3 to router 6 and router 7. Now I do show IP OSPF neighbor. And we can see now that it's attempting now to be adjacency, to have adjacency between router 3, router 6 and router 7. We have to wait a little bit before it comes up. So we can see now router 6 become enabled for router 3. And of course you have to know these start, two-way, all of these stuff in the CCNP level. So here, in this case here, they are exchanging the DBD. And here it is now up. So now I can see router 6 and router 7, they are enabled for router 3. Now one more thing to say here, to finish from this case, that router 3 should be for this area over here. Router 3 should be the hub, and those should be the spoken in this primary network. Now, if we look to this result we have here, we see that router 3 is the DR, and router 7 is BDR, and router 6 is DR other or DRAZL. So we don't want that any routers from 6 or 7 to be BDR or DR. So we want them to be always DR other, and we want router 3, this router, to be always the BDR for this area. To do that, I have to go to router 6. Inside this sub interface, I will say IP OSPF priority is 0, because by default priority is 1, so we set it to 0, means that it will never be a DR or BDR. I do the same here on 7, IP OSPF priority is 0. Now, if I go to router 3 again now, I do the same command, I will see nothing has changed. And the reason why is because we have to clear the process of OSPF. So I will go to router 3 and I will say do clear IP OSPF process. Yes, and I will do the same for router 7. Do clear IP OSPF process. Yes. So it takes a little bit of time now, so 6 is back on. Let's check. So indeed 6 and 7 they are back on now, and you can see they are full browser or DR other, means they are not the DR or BDR. So if you go to 6 for example, and from here you say show IP OSPF neighbor, you can see that the 6 see that now router 3 is the DR. The same for router 7, show IP OSPF neighbor. Also they see the router 3 is the DR. Okay, sounds good now. So in this stage until now, I think it should be okay now on router 1 to see 6 and 7. We already solved 9. But let's try again now to see if we can see 6 and 7. So 1 is himself, 2, 3, 4, 5, 6 indeed, 7, 8, and 9. Okay, so now if I do ping, of course 2 is not a problem, 3, 4, 5 not a problem. Let's try 6 now. It's okay. You can see it's a little bit slow because I'm running a lot of processors on my PC now because of this lab. It's a 9 routers lab and I'm recording, so it's a little bit slow, but yeah, it's okay. We can see the result, and I will do one more for 9 because we had the problem on these routers. Okay, beautiful. So it's one question here, but it took a lot of time to solve the problem. So ensure that router 1 can ping our router. We did it. Now redistribute the external route of R1 to the OSPF area. The metric should be 50 and should not change as it goes to all other routers. Now, if we check on the lab here, router 1 has external routes which are 10.0.1.2.3. So we need to redistribute this external to these areas, and as it goes inside the areas, it should not change the metric, and the metric should be 50 and should not be changed. Now, if I go to router 1 and I do show run includes section IP route, you can see that I have created a couple of static route which go to null, just to be able to make the distribution of static route or external network. So now on router 1 I have to go and say router or OSPF 1 redistribute static, and I will put subnet needs to redistribute also the subnet mask, and then the metric they said should be 50, and then the metric type, we have two types, we have 1 and 2. 1 means it will change as long as it goes into the areas, and 2 will be set the same, so it will not be changed. So I will choose 2 and enter. Now if I go for example to router 4, I do show IP route. I should be able to see this external routes. Yes, indeed. So you can see that these external routes are shown as E2, which I choose it as type 2, and you can see here the metric is 50. And router 4 is a little bit far, is here. So if it was type 1, it would be adding these paths. So let's go to router 9 and check. Show IP route. Yes, indeed, they are here, and also the metric is 50. Okay, so we go to the next step. After redistribution is done, you should summarize. Yeah, there's a mistake here. You should summarize it so all router can see only one entries on the routing table for external routes. So if we go back to router 9 here, we can see that router 9 is seeing 3 entries. So we need to summarize these 3 entries to be only one entry. And to do that, we have to go to router 1, and over here I have to say summary address from router and question mark, and the summary of this route. The summary of this route is let me check, 10.0.1. Okay, so it's 10.0.0.255.255.252.0. So you should know, of course, at CCNP level how to do the summary. And enter. Now, if I go back to router 9 now, and I do again show IP route. So this is how we do the summarization for external route. Let's see if it is working now. And yes, indeed, you can see here it has been summarized /22. So this is okay. Now, step 5, configure OSPF authentication MD5 area 0 with key Cisco. And ensure that all router and area 0 can see each other again. Okay, area 0 is router 1, 2, 3, 4. Okay. Router 1. So go to the interface, file system net 0/0, IP OSPF authentication, authentication message digest because it's undefined. The IP OSPF message digest key, choose one, MD5 and Cisco. Oops, it should be Cisco. Okay, so I will do it again. IP OSPF message digest P1 MD5 Cisco. I'll do the same on router 2. Interface file system 0/0, IP OSPF authentication message digest, IP OSPF message digest key 1, and it should be the same key of course, in Cisco. Router 3, it's getting a little bit slow because of the processor. IP OSPF authentication message digest, IP OSPF message digest E1 MD5 Cisco. And finally on router 4, interface file system 0/0, IP OSPF authentication message digest, IP OSPF message digest T1 MD5 Cisco. So you can see here it's going down because there's no authentication on this router. So now we should have again formed neighbors. So we see here on router 1, router 2 has been formed again. I do show IP OSPF neighbor. Router 4 is back on also. Router 3 is back on. So the routers went down and they came back again now. So router 1 can see router 2, 3, 4. Then we are fine. Okay, now we have to configure OSPF plain text authentication on area 25 and also key Cisco ensure that all on area 25, not area 0, can see each other again. So router 25 is what? Is router 2 and router 5. Okay, so I go to router 2 under interface 0/0 IP authentication, IP OSPF authentication, and here I don't say message digest because it's clear text, and then IP OSPF authentication key at Cisco. That's router 2, I go to router 5, interface 0/0 is, oh, I think I have made a mistake, it should be under 0/0/0.1. So here I did it on 0/0/0. So I'll take out then these comments. So let's do router 5 this time. IP authentication, IP OSPF authentication, IP OSPF authentication key 1 Cisco. Router 5, now router 2. I should go to the sub interface and not to the main interface, the physical interface. So interface. So we see now that it's dead with router 5 because there's no authentication. Now I say IP OSPF authentication, IP OSPF Authentication key 1 Cisco. We wait a little bit and the neighborship will be formed again. So let's do, you can see here is back on with router 5. So I do show IP or OSPF neighbor, and router 5 sure is again online. Okay, now step number 7, they asked us to configure loopback on router 9 and advertise them on OSPF. The router 9 is on area 89. I think I have already configured the loopback, so let's check. I show IP or OSPF, show IP interface brief. Yes, I have configured the loopback, 172.16.1.9, 2.9, 3.9. But I haven't advertised them into OSPF. To be sure, let's check router OSPF. Yes, I haven't advertised them, so let's do it. Router OSPF 1 network. I will do it in this way. 172.16.0.0.0.255.255 area 89. Enter. Okay. So I have advertised them. Ensure that all routers see only one entry for this loopback on the routing table. If I go, for example, to router 1 and I do show IP route, I should be able to see these 3 loopback interfaces as enter area, and yes, here they are. These 3 loopback advertised in OSPF. So I should make a configuration in a way that router 1 can see only one entry, which is a summary entry for these 3 loopback. To do that, I cannot do the summary on router 9 because router 9 is an internal router. It should be on a ABR router, and router A is an ABR router. Area border router. So I will have to do it on router A. So I go to router A, and router OSPF 1. I say area 89 is the area I'm working on. Range, that's the column. And what are the IP? 172.16.1.9, 2.9, 3.9. So then, okay, I know what the summary. It will be 172.16.0.0, 255.255.252.0, and enter. So in this way, I will go back to router 1 now, and I do again show IP route. And yes, I can see here that these 3 loopback has been summarized into one IP, which is /22. So if I do ping 172.16.1.9, should be okay. Yes. Okay. So this is how to do the summary for loopback or for inter areas. Now, R6 and R7 should not have the external route in the routing table, but a default route to R3. You are not allowed to configure a static default route. So we have, if you remember from the first steps, we have redistributed this external route, and these have been redistributed to all the areas and all the routers. So what they ask here is because 6 and 7 there are no any other routes after them or routers, so they should not really care about this external route. They should not be having this into their routing table. So all they need is an exit entry to go to this router, and it should be on router 3. So they don't really need this route to be advertised to them. So if we go to router 6, for example, and I do show IP route, you can see here that this external route, which has been summarized, they are shown on the routing table, but they don't want really to see that. In order for this to be solved, we have to go into the area which is 367 and do the area as a stub. To do that, I have to configure stub on routers 3, 6, and 7. So let's go to router 3, go router OSPF 1, area 367, and the command is stub. Yes, and I do the same. Directly go down because the stub should be inside the hello packet, and when they exchange hello packet, they will see that this is stub and the other are not stub, so they will not form any adjacency. Router 6 now, router OSPF 1, area 367, stub. Router OSPF 1, area 367, stub. Now, if I do show IP OSPF neighbor, okay, so it will take a little bit of time before they form the adjacency between routers 3, 6, and 7. So IP OSPF neighbor. So now the state is down. So down means hello has been sent from the neighbor. Then it will go to init. Init means that he checked if the hold time or the hello receiver is correct, and then they will send it back to them. It will go to 2A, and when they agree, then they will go into exchange. There was exchange database table, and then after that they will go to loading. So if they need any information about the route, they send LSA and LSU, and finally they will become full. So now it's still down. Okay, now it's loading, and yeah, it should be okay. Now it's full. The same for router 7. So let's check now if on router 6 the external route is still showing. Okay, so yeah, now it's okay. So as you can see here, there are no more E2 or external route, but this has been changed into a default route inside OSPF. The same happened to router 7. Do show IP route. Also, there are no more external routes over here, but a default route, which is an exit to router 3. Okay, so this is 9, and the last step, router 5, this router should not have external route, neither inter-area routes. So they don't want to get external, and they don't want to get inter-area, means route from the other areas to him, because he is the last router or in this area. So you just need to have a default route to go to router 2. And we are not allowed to use or to configure a static route manually. So, in this case, we have to configure router 2 and router 5 to not have inter areas and external route, and this is called a totally stubby area. And this has to be configured on router 2 and router 5. I go to router 2, router OSPF 1, and the command is area, I think it's 25. Yes, area 25. And stop, and then I say no summary. This means it's a totally stubby area. And then I go to router 5, router OSPF 1, area 25. Here I can say only stop, because router 2 has been configured as totally stop. So this we can put it as stop, and then it will become a totally stop, of course, with router 2. You can do both, but I will do it this way. So it's resetting now. Now it's back on. So if I do and show IP OSPF neighbor, so they are full. So if I do now show IP route on router 5, so I don't see any inter-area anymore, I don't see any external route, I only see exit to router 2. But I can still ping, for example, 3.3.3.3. Even if it's not in our routing table, but we can ping it. Of course, here you can see this. It doesn't mean that they cannot reach it. It means that my processor on my PC is getting too high, so it's not able to send this ping. Okay, so I assure you that it's working. Don't worry. I will try to do it on forward. It is working, I assure you. Don't think that it's not working, but because, okay, I will show you to believe me. Yeah. You see my CPU usage is 100% because I'm 9 routers, I'm recording, so yeah, that's why the packets are not going. Anyway, I hope you enjoyed this lab.